Hello.
Hi, Karen. Thank
Hey.
thank you so much for asking for the office hour.
Mhm.
You're the only person who responded to my request for requests, so thank you.
Well, I do need the help, so of course.
Okay, I'm gonna get you to tell me if the focus is okay.
Yes, the
Thank you. Let me
focus.
pin it. Is it
Yeah,
is it okay?
yeah, it's okay.
All right.
Before we start, I still don't see the special homework on Blackboard.
What?
I still don't see the special homework on Blackboard.
You had all right, let me double check and make sure that it's there, okay?
Mm-hmm.
And oh my gosh, extra credit. I'd forgotten to make it visible. Now, can you refresh and see if it's there? Oh my
Okay.
gosh. Thank you so much.
Thank you.
No, no, really. And I owe you extra credit. I have your email
Yeah.
and I will respond this weekend to all of the extra credit emails, but you just earned 5 points extra credit
Yes.
because I did not realize it wasn't visible.
Um,
Oh my gosh.
okay.
You
Okay.
know, it's so funny. Blackboard is so funny. And I have to post it, but then there's another step where I make it visible.
Mm-hmm.
And I don't really necessarily realize that step. It's not apparent, if you know what I mean.
Yeah.
Okay. So did you want to look at WebAssign if you had some specific
Yes, because
questions?
I wasn't seeing the special homework, so I really want to focus on the web assign first.
That's what I thought maybe. Yeah. Okay.
Yeah.
All right. So I'm going to get into WebAssign and you're going to tell me, are you part one or part two?
Part one.
Okay. Got it. And I'm going to make this student view so I don't give away the farm. And I'm going to share my screen with you.
Mm-hmm.
And then you can tell me what it is that you need some help with.
All right.
And I'm going to
Um,
move this whole thing out of the way. All right, which one are you looking at?
we could start with the first one
Okay,
and then do one of the factorials in the bottom.
okay.
Yeah.
So, do you realize that you are being given the general formula for the general term? I think in class we called the term A sub n, but it really doesn't matter what letter is used to give the indexing, right?
Mm-hmm.
So I'm going to just write and then I'll make this a little bigger so you can see it.
Let's see.
So number one, can you read what A sub k is in yours?
A, A of K is
A sub k.
A sub K equals K over 11 plus 4 plus K for
Okay.
every integer K is bigger and equal to 1.
Okay. So notice how they gave us, I'll stop sharing for a minute so we can look at it. But
Okay.
notice they gave us the formula for the general term.
Mm-hmm.
And then they told us where the indexing starts. So let's just make a note of that. You see, in class, we used N, A
Mm-hmm.
sub N, but it doesn't matter what letter we use. It can be K or J, as long as the indexing letter, that variable, is appearing in the formula.
Mm-hmm.
So this is the formula for the general term. and this is where the indexing starts. Does that make sense? Can you see?
Where the indexing starts is if k is bigger or equal to 1.
Yeah, I want to make sure this is close enough that you can
Okay.
see it really well. There we go. Can you see that?
Yes.
So let's go ahead. It asks you to find what, the first few terms?
Yes.
What are the instructions?
The instructions are, I have to go back on my thing. The instructions are find A1, A sub 1, A sub 2, A sub. Oh, so I'm gonna input that in.
Yep.
Oh, I'm sorry. When I saw the problem, I couldn't figure out how to do it. And then now that I'm with you, I feel it's like it doesn't make sense. I'm sorry.
No, don't be sorry.
A1
Let's do the first one. What is a sub 1? You tell me what to
is
write.
1 over 11 plus 1,
So we'll write that as 1 over 12.
12. Yeah.
So always use fractions, not decimals.
Okay. Use fraction.
And do you know on your calculator, there's a function in the calculator called uh,
SD.
math frac? Maybe for you it's SD, but with the calculator, I have a TI-84 or
Mm-hmm.
TI-83. I don't know what kind you've got.
I have a FX 9750.
Oh, wow. I don't know how to get fractions with that, but you can always Google that for
Mm-hmm.
your calculator. Uh, but with these other ones, there's a math button, and then the first choice is for fraction.
Okay.
But you'll have to Google your calculator. It sounds like you've got a pretty advanced calculator.
Okay.
Okay. But,
Yeah.
honestly, you can do this without a calculator.
Yeah. Actually, you we can stop here. I
Well,
don't know. I just
did you want to look at one of the factorial ones?
yes, I think the factor would be better for me because I genuinely
Because
don't
now you can
understand.
understand all of
Yeah.
these, right?
I'm looking at problem 4 though.
Yeah,
Problem
that's a fun
4.
one. Now, we did something similar in class on Thursday.
Mm-hmm. Find an explicit formula. Yes, problem 4.
Uh-huh. We did something similar. Uh, let's take a look at number 4 together. All right,
Mm-hmm.
so I'm going to write the sequence first, and then we can look at it together.
Okay.
All right, so the first term is 1 minus 1 over 4, right? The next
Mm-hmm.
term, you tell me the terms. What's the next
Okay.
term?
1 minus 1 4,
Uh-huh.
comma 1 over 2 minus 1 over 5,
Okay,
comma 1 over 3 minus 1 over 6,
gotcha,
comma 1 over 4 minus 1 over 7, comma
gotcha.
1 over 5 minus 1 over 8, and then comma 1 over 6 minus 1 over 9.
And what it says, find you read the
Formula.
instructions.
Find an explicit formula for a sequence of the form A1, A2, A sub 1, A sub 2, A sub 3 with the initial terms given below.
Do you notice that information that they are giving us in the question?
Yeah.
What is the information that they are giving us uh, in the question uh, that helps us understand where to start this?
They're giving us A1, A2, A3 and a formula.
Yes, right. They're telling us that A1 is where the sequence starts. And that means they're helping us. They're telling us the indexing starts with 1.
Oh.
And that's really helpful because that means this term is A1, and then the next term is A sub 2, and the next term is A sub 3. See what I mean? That's
Yeah.
going to help us correctly connect the relationship between the indexing number and the term formula.
Oh.
Because now we know we have to start with one. So somehow we have to connect the number one to what's going on here. And we
Mm.
have to connect the number two to what is happening here. And the
Mm.
number three, you see what I mean?
Yeah.
And like I said, we did one similar, but I'll show you what we did on Thursday, and this might help. Okay, so A sub, and I'll put the one in red because the one is what really matters, okay?
Mm-hmm.
It equals 1 minus 1/4. Now, I don't really see how the one relates there yet, okay? So let's just leave it and look at the next one and see if we can start to see a pattern.
Oh, I'm already seeing a pattern.
What are you seeing?
The first number changes, like 1/1 is the first one, then A2 is 1/2.
Right. The first number in A1 is 1/1. And the first number in A2 is 1/2. I think you've got half the pattern. All we have to do now is figure out how the second fraction is related to the indexing number.
I think it adds up every time.
Oops. Yeah, what does it add up? What's
Uh,
happening?
one adds up every single time when it went from 4 to 5 to 6. Yeah. No,
Yeah.
yeah.
So we need a relationship between 1 and 4. And same relationship has to be between 2 and 5. And that same relationship has to be between 3 and 6. And that same relationship has to exist between 4 and 7. So what is that relationship
Um, um,
between 1 and 4,
three,
2 and 5?
three,
3.
three,
Yeah,
three.
3. What about 3? Be specific.
Oh, 3 gets adds up in the second fraction.
Yes, 3 gets added in the second fraction. So 4 is 1 plus 3. 5 is, tell
2
me,
plus 3. 2 plus 3.
2 plus 3. Great. And 6 is
3 plus 3.
3 plus the same 3. And 7 is,
4 plus 3.
see, you got it. That's the relationship. And now that you see what's happening for 1 and for 2 and for 3 and for 4, what do they ask us to give? A sub k or a sub n? A sub n. So we want a formula
Mm.
for a sub n.
This is totally different from what we learned in class Thursday, right? We're not gonna use pi or sigma, are we?
No, we're not to products and summations until WebAssign part 2.
Okay, okay, okay.
But we worked on this sort of thing on Tuesday, and we
Mhm.
had a do now problem on Thursday. And I think it was similar to this. If you look,
Mhm.
it wasn't exactly the same, but if we look at the class notes from um, we look at class notes from day 16. Oh, no, that was our do now. Okay, hang on. Let me see if we get it. Oh, here it is.
Yeah.
Do now number two. Find an explicit formula for the sequence. And it was a difference of fractions. It was similar
Oh,
because I knew you were going to get this problem in the WebAssign. See,
yeah.
I always try to give you enough.
Oh, it's gonna be the same formula, but instead of two, we're gonna add three.
Exactly.
Okay.
Does that
Okay.
make sense?
Yeah, 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 yeah.
And that's so those lectures have a plan.
Yeah.
So A sub n is going to be what?
It's gonna be an equals 1 over n minus 1 over n plus 3
And then they didn't ask you for this because
for
they told you. Yeah, but you tell me, yeah, for
every integer n bigger than 1.
that's exactly right.
Hmm. I wonder
You
how that works for a regular number to find a pattern. Is it gonna be like we can use other fractions when we're doing the formula? We can
you
use
just
one fraction?
yeah, you see this sequence that they gave us,
Yeah,
it is neither arithmetic nor
they're
geometric.
metric. Oh,
It's
okay.
neither one. Like we don't get from A1 to A2 by multiplying by something or by adding something. You know,
Mhm.
it's not arithmetic. There's no common difference between terms. It's not geometric. There's no common ratio between the terms. It's neither. So not every sequence is arithmetic or geometric. Sometimes it's just a sequence that has a pattern and our
Mm-hmm.
job is to try to detect that pattern.
All right. That works.
It does.
It does. It does
Do you
work.
want to peek at special homework 8 with me now? Shall we take a peek at it together?
I wanted to try the factorial.
Oh, no, let's do the factorial. Absolutely.
The
I think,
factorial before I get
yeah,
to the
yeah, yeah,
homework.
yeah, yeah, yeah. Okay, so
Okay.
let's go back to WebAssign and factorial is, so the first one is number 7 and then 8. Oh, I gave you a lot of them. 9. Oh, and 10.
And 10 is the one that is the hardest, but I want
Oh,
to first start with the first one.
okay. Now, do you remember the nice relationship with factorial?
I think I remember that you can do 4, 3, 2, and 5.
Mm, 4, 3, 2, and 5.
I mean like maybe no. Actually no. I don't know.
All right, I'll tell you what. I'm just going to write the problem 7 down, and then we're going to talk about factorial a little bit. And I'll see if I can get you there without just giving you the answer. Okay?
Oh, okay.
Now, is your number 7 7 factorial over 6 factorial?
No, it's a different number, but I can use that.
Same idea. Okay. So just recall the definition of factorial.
Mm-hmm.
All right. The basis is we're told that 0 factorial is 1. So
Mm-hmm.
it's just by definition. The
Mm-hmm.
bottom line is that if we defined 0 factorial to be 0, then nothing would work
Mm-hmm.
because we'd wind up trying to divide by 0 far too often. So this is just given. And then n factorial, well, what is it? It's n times the factorial from n minus 1. And this is for n greater than or equal to 1. So we have a definition for 0 factorial, and when n is 1 or larger, we have a factorial definition for that value of n.
Mm.
Okay, now let's just look at some examples. 3 factorial, it's really 3 times 2 factorial because 3 factorial, 3 is bigger than or equal to 1, so we use the recurrence relation
But how did we go from n minus one to two?
because, well, let's just look at it. Let's look at the formula. 3 factorial, so n is 3, right?
Mm-hmm.
So we put a 3 in there,
Mm-hmm.
and then we put a 3 in there, but that's 3 minus 1
Oh,
factorial.
equals two. Okay. Okay, let me write this down.
But it makes sense because 3 factorial is 3 times 2 times 1, but 2 times 1 is 2 factorial.
Mm,
So it's 3 times 2 factorial. 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's actually what 10 factorial is. But all of this is 9 factorial. So in fact, 10 factorial is 10 times 9
nine.
factorial. It's just, see what I mean?
Yeah, yeah, yeah.
We just have a shorthand way of writing 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1.
Mm-hmm.
We write it as 9 factorial. But also 10 factorial is 10 times 9 times 8 factorial. If we wanted to see an 8 factorial, let's say to cancel with maybe an 8 factorial in the denominator if we had a fraction.
I don't understand. How did the eight come again?
Well, what is 9 factorial? It's
Nine.
9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 8 times 7 times 6 times 5, that all is 8 factorial. See? From from the 8 to the 1 is 8 factorial. From the 9
Like
to the 1
numbers?
is what?
One, two, three, four, five, six, seven. From how I don't get the 10 times 9. I don't understand
You're
how.
thinking about it too hard. Let me see if I can. Do you understand that 10 fact have you ever heard of factorial before?
Oh,
Okay. Well, in general, when we're in high school and we learn about factorial, all that you're usually taught is that 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I mean, in general, like students are taught, oh, you know, 5 factorial is 5 times all the numbers less down to 1 times 4 times 3
oh,
times 2
okay.
times 1. See,
Mm-hmm.
that's usually the way
Okay,
people are
yeah.
taught.
Mm-hmm.
But if you realize that 4 times 3 times 2 times 1 is another way to write 4 factorial, then you
Mm.
can see that 5 factorial is really 5 times 4 factorial.
Okay, I understand. So if I wanted to take the factorial of three, the factorial of three would be two times one.
Yeah,
If I
3
wanted to take the
factorial is just 3 times 2 times 1.
okay, I understand. Mm,
But another way to write it is
using the formula,
using the formula
the
because 2
definition.
times 1 is 2 factorial.
Yeah. Yes.
Okay.
Okay. Mm-hmm.
So no matter what you get, in your problem, is the top number one more than the bottom number?
In mine,
And
yes, the top one has more than the one under,
I
but there's
mean, is the
also
top, is
some.
it,
Mm?
what are your numbers?
I have 5/4, then 4/6.
Stop. 5
Mm,
over 5 factorial over 4 factorial.
yeah.
So you have n factorial on the top. We'll just call it n,
hmm
where your n is 5, over n minus 1 factorial, because on n minus 1 is 4. You see what I
Mm-hmm.
mean? Like mine is 7/6. Yours is 5/4. The
Mm-hmm.
computer is generating problems where the top number is one higher than the bottom number.
Mm-hmm.
Well, we know that n factorial is n times n minus 1 times n minus 2, keep on going, times 3 times 2 times 1 until it gets all the way down to 1.
Mm-hmm.
You see that?
N minus one minus
Because this is the integer before. Like if you draw the number line,
two. Mm-hmm.
here's n, but the one right before it is n minus 1. The one before that is n minus 2. Do you see it?
Mm-hmm. N minus two minus three minus two minus one. Okay.
Until you get down to, 3 times 2 times 1. Like we don't know how big this is. Oh, sorry.
Mm-hmm.
You couldn't see.
Mm-hmm. Mm-hmm.
But, n times n minus 1, n minus 2 is behind that, n minus 3 is before that. Oh, n minus 5 would be this one. It's one less than n minus 4. And you just keep on going down times 3 times 2 times 1. Does that make sense?
Yeah.
Well, down here, we have n minus 1 factorial. So that's n minus 1 times
N
the
minus
integer
two
before, n minus 2. Keep
minus
on
three.
going until you get
Mm-hmm.
down to 3 times 2 times 1. See what I mean?
Oh, okay. Okay, 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 okay. Yeah, yeah, yeah. I see. I see. Yeah.
And look what all cancels. The 2's cancel, the 3's cancel, the n minus 2's cancel, the n minus 1's cancel,
Yes.
and we're left with n
And
over 1, or
one.
just n.
Yeah. I see. I see. I see.
And this idea goes to problem 10. Now, we did a couple of problems similar to problem 10. Let's take a look at a couple of problems because we did this in class. In fact, let's look at the notes. We did this on Tuesday. See, I tried to sneak up on the more complicated problems because look at our first problem. It only had the one fraction, the 1
Mm-hmm.
over 1, the 1 over 2, the 1 over 3, the 1 over 4. You see what I mean? It was
Yeah.
simple. It was just 1 over n. But then the next day, we made it a little more complicated in our do now number 2. So you should make use of the class notes. Are you making use of them?
Yeah, I do, but the how will I say, for some reason, because I'm writing it, maybe I might have to change the way I write my notes. When everything is together, it's hard for me to see the informations that I need. So that's
But
on me,
that's
though.
why I
That's on
post,
me.
but that's why I post the notes.
Yeah.
I mean, if you read these notes, are they easy to read?
Yes, they are. Because you have color and stuff. Like, yeah. I like seeing the ones online. That's why I was asking you in class if you were gonna remove them, but you were like, no. I was like, okay.
I'm not going to. I'm going to get in trouble because they're not accessible, but too bad. I don't understand why they want me to take away something that helps you.
Yeah.
I have to do voiceover recordings with each of these sets of notes, is what I have to do
Oh,
to make it fully accessible.
accessible.
Anyway,
Yeah. Yeah, okay.
so we did this one, n
Mm,
plus 1 factorial divided by n minus 1 factorial. So
mm.
n plus 1 factorial, what is it? It's n plus 1 times the integer right before. Well, the integer right before n plus 1
Zero.
is n, right?
Yeah.
Times the integer right before that. That's
Minus
n
one.
minus 1.
And you
And we
can.
could have written times dot 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 times 3 times 2 times 1, but we know that that's the same down here. N
Mm-hmm.
minus 1 times n minus 2 times dot 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 times 3 times 2 times 1. Do you see what I mean? Like we don't have
Mm-hmm.
to write all that to realize that n minus 1 factorial appears in the top and in the bottom, and they can cancel. They're just a bunch of factors multiplied together. So what's left is the n plus 1 times n. Does that make
And
sense?
Mm-hmm. Hmm. That makes sense. I think I
So
got
for our do now on Thursday,
it.
we practiced another one. Okay. Like we practiced with some numbers. You see how we practiced with some numbers?
This times 5 times 4, 4. Um, what happens if the upper part is smaller than the down part?
Then you would get a fraction that's between 0 and 1.
Okay.
I will tell you, that would be it would be possible, in some applications, but in our applications, we will always have the upper number larger. It doesn't have to be that way theoretically, but in our applications of factorial, which is n choose r, you have a set of size n. It has n elements, and you're counting the number of different subsets that have r elements. And the formula for n choose r
Mm-hmm.
will always wind up giving an answer that's 1 or larger,
One or larger, yeah, like the definition, yeah.
right? Number 2 is actually the formula for 10 choose 7.
Mm-hmm.
So this is the formula for if you had a set with 10 elements
Mm-hmm.
and you needed to count how many subsets that have 7 elements each you could
Mm-hmm.
find, different ones. So you imagine you've got the urn with 10 marbles and they're all numbered, and you reach in and you grab 7 at a time and you look at the numbers and write them down. How many different ways could you do that? Well, there's 120 different subsets of size 7 from a set of size 10.
Yeah.
Now, in number 3, this is the formula for n plus 3 choose n, actually. But you don't need to know that to work the problem.
Mm-hmm.
The top is n plus 3 factorial. So
Mm-hmm.
downstairs we have an n factorial. Now,
Yeah.
n plus 3 is bigger than n, right?
Mm-hmm.
So we're going to expand n plus 3 factorial down and down and down until we see
Mm-hmm.
the n factorial, and we can stop there because we have an n factorial in the denominator, and we know these two factors, these are all being multiplied together. All these integers are getting multiplied. So we
Yeah.
just can cancel n factorial from the top and n factorial from the bottom. Do you see that?
Mm-hmm.
Does that make sense to you?
Yeah, but the 3 factorial down, then we do 3 times 2 times 1.
Exactly.
But why are we doing that? Is it because up there there's 3, 2, and 1, n plus 3, n plus 2, n plus 1, so we do the same
That's a
bottom?
coincidence. That's a
Oh,
coincidence.
yeah.
I just was writing what 3 factorial is just to make sure that everyone in the class understands that 3 factorial is actually the number 6.
Hmm. Okay. Because
It
it's all
said
the numbers before
simplify.
it.
It said
Yeah.
simplify. Well, see, actually, I just said do now. I didn't even give instructions. I should have given simplify completely, right? Well, this
Okay.
is simplified completely. If you can get rid of a factorial and just have a single integer
Oh,
without the factorial symbol, just the
yeah.
integer is considered simpler.
Okay. So when we're simplifying, the exclamation point needs to be out. Okay.
If we can do, yeah.
Okay. Okay. That works. That works. That works. I understand.
And I bet you can do number 10 now.
Number 10, yeah, we already did it. I have to replace the one with 3.
Okay.
Mm-hmm.
Huh.
It's just those, and I want to go look at the
Now, wait
spec.
a second. What was your number 10? Tell me what your number 10 was because it might be
Mm,
tricky.
okay, my number 10 is n factorial over n minus 3 factorial.
That's a little tricky.
Oh, okay.
I'm going to show it. I'm going to do n factorial divided by
N
n.
minus 3 factorial.
Well, I'm going to do n minus 4
Oh,
factorial.
okay, okay, okay.
All right. Now, N factorial is bigger than n minus 4 factorial because n
Mm-hmm.
is bigger than n minus 4, right? So we're going to expand the n factorial. Oh, it'll be okay. You'll know how to do it.
N minus 1. Okay. N. And then we stop at n minus 4 because of down. So,
Yeah, because our goal is to cancel.
yeah.
Okay. Things get more interesting when we get to n choose r, because then we have the formula for n choose r. It's n factorial divided by r factorial times n minus r factorial. Everything we've done so far is practice to understand this. And the thing you have to be careful about is the n minus r factorial.
But wait, this is a continuation of number 10?
No,
Oh, okay, okay,
this is part two. This
okay.
is section 5.1, part two.
But yeah.
All of this work that I gave you on
Mm-hmm.
Tuesday, from part one, is
Mm-hmm.
just practice so you get comfortable with
With
the
part 2.
arithmetic so
Mm-hmm.
that then when we try to use factorial to actually find something
Mm-hmm.
important in choose R, that you are comfortable with the arithmetic and can go on to the next
Mm.
step of complication.
All right.
So, for example, n choose n minus 3. Now, this is different than n factorial divided by n minus 3 factorial. This is different, okay? Because by the formula, it's going to be n factorial because the n is on top. Downstairs, we have to put r factorial, but what is r here?
R is n minus 3.
So the r factorial is now n minus 3 factorial. And then we need n minus r
So it's gonna be
factorial.
n minus 3.
So we have to be careful, and then we factorialize that. We have to
Oh,
be careful because this minus sign has to get distributed across the entire expression n minus 3. So we have to distribute the minus sign.
um, oh, mm,
All right, so up top we've got n factorial. Down here we have n minus 3 factorial. All right, and then we have n minus n what? What happens when we distribute this minus?
n square.
Oh, no, no, it's just a minus. It's not n
Oh,
times n. It's
n
n
minus, oh, it's gonna
minus
be
n.
negative R.
Yeah, our negative r is
Um,
negative.
negative 3, sorry.
Well, what's a minus 3 though?
Plus, so plus
And
3.
that's what I'm saying. You got to be careful that you make this a
Oh,
plus, because otherwise you would have negative 3 factorial, and we don't have a negative 3 factorial because factorial is not defined for negative numbers. So it's important you distribute the minus sign. So what is n minus n plus 3 if you were going to simplify that?
3.
Yeah. So what we get is n factorial on top, n minus 3 factorial, that's our r factorial
And
still
3
there,
factorial.
but our n minus r factorial becomes 3 factorial. And this should look familiar because there's always going to be a relationship in these n choose r problems. The quantities in the denominator have to add up to the numerator. So n minus 3 plus 3 is in fact n. The
Mm.
formula always works like that. Does that make sense?
Yeah, yeah, yeah.
And now you have the tools to simplify this because you know what to expand and what to cancel, and you know what 3 factorial is.
Yeah. 2 factorial is 6.
Right, so simplify completely.
N minus 3 would be n minus 2 minus
N times n minus 1 times n minus 2. Keep going
n minus 3. And we stop there and we go
with a factorial.
um
Good. And then we
n
have,
minus 3 and 6.
don't forget your factorial.
3 times 2. Oh, okay.
So our answer is n times n minus 1 times n minus 2 on the top. And on the bottom, we have 6.
3 and 6 and n minus 1 n minus 2 n minus 3 equals n and oh, okay.
Does it make sense?
So yeah, over 6. Yes, it does.
That's great. Do you see how all this work that we practiced,
Before,
now we finally actually use it for a real formula, the formula for
yeah,
in choose R. But we needed that skill set, right? We needed to know how to deal with n factorial divided by n minus 3 factorial to be able to do the work.
yeah. The only thing that I would get confused at is the n minus 3. I thought that we were supposed to multiplicate. I didn't know we were like subtracting because I was about to say n square,
I
but
know,
n
but
minus.
this doesn't say times R, does it?
Mm-hmm.
It says minus R. So
Yeah,
you're right. We have to pay attention to the mathematical operators, the arithmetic operator there.
yeah. It's
It's
not that
not n
hard.
times minus R. If it was n times minus R, we would have to have a parentheses around the minus R.
Mm-hmm.
So I remember when I was learning this, when I was younger and learning algebra, that I didn't understand the notation and
Yeah.
subtracting and the difference between that and multiplying by a negative number really
Oh,
took a while for me to figure out the difference.
I mean, now you're perfect at it, so hey.
No, 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 no. I'm never going to be perfect at anything, but practice makes it easier. And with the help of good students, when I do make a mistake, somebody catches it.
Yeah.
And that's the beauty of a good class.
Mm-hmm. But now with all the material you just gave me, I think I can confidently start my homework.
That's
Because
wonderful.
I just needed some recall. Because it's good to read the notes, but sometimes you have to hear the voice of your teacher and be like, okay, I think I can focus now. But yeah.
I'm so happy that you asked for this office hour. And now I'll be able to put the recording up for other people who had to work or had other obligations this afternoon. So thank you, Karen.
Yep.
And please, please, please email me for 5 points.
All right. I sent you an email for because I,
Uh,
I couldn't see the special homework, so don't mind that email.
thank
Yeah.
you.
Okay. All right.
Thank you.
Mm-hmm.
All right. Anything else I can do for you?
Nope, ma'am.
All
Have a
right.
great evening.
Thank you.